Okay, so in this video, I'll pick up where I left off in the previous video, which was working on. Looks like I got some feedback. How do I turn that off? Working on. Looks like I got some feedback. Cool. All right, so yeah, still figuring out how to do this whole live stream thing, but yeah, and I also got some feedback to try to talk a little bit louder. I think I was getting a little bit quiet, and save. So I'll try to be a little bit louder when I am speaking, and yeah. So really, we're just going to pick up from where we left off last time. So what we were doing is we were implementing a new SocketWorker. We had finished refactoring VirtualWorker and the relationship between VirtualWorker and BaseWorker, so that we only have to override two methods, send message and receive message. And we were in the midst of doing so, and we have pretty much finished send message, with the exception of messages that require a response, that we actually want to hang until they receive a response. So right here, hang until receive response. Right? But for ones that do not need to wait and receive a response, like sending an object from one worker to another, we found that we already have functionality working for that feature, right? So there's just these two methods left, where one of which is actually, I should go ahead and annotate these. So this is sending an object from, or sorry, receiving an object from another worker. Make sure there's no white space there. Okay, and then this one, I think it's supposed to be 2. This one is requesting an object, or receiving a request for an object from another worker. And then this one is a torch command involving one or more tensors hosted locally from another worker hosted locally. Perfect. Yeah. So this command is already functioning, whereas these two have yet to function. And if you're not quite sure where we are in the context, I would encourage you to go ahead and check out the video previous to this, which also includes a general tour of the code base, and of course includes all the changes that we made in the last 4 or 5 hours. But yeah, so, and of course I'm also going to try to do a better job of hanging out on the chat here and here. So feel free to message me if I'm going too fast or you have particular questions. Although, since this is my second stream, I expect that this will mostly be here for historical purposes if people have questions about this particular part of the code base. So let's jump back in. So we were running these receivers, a sender and receiver. We had just replaced, or we had kind of these two socket workers here, one of which was a pointer, and the other which, or excuse me, one of the which is not a pointer, but is a client, and the other which is a pointer. So is client worker equals true. Cool. Yeah, so let's just rerun the functionality that we had before, sending one object to another, just to make sure everything looks good. We're going to say listen, and what should happen is I should go over to this sender, and I'm going to I'll go ahead and reboot this. So what I'm going to do is I'm going to override torch here. I'm going to create a tensor. Then I'm going to create a local worker, a pointer to a remote worker. Oh, just be on the correct port. And then I'm going to send a message. And this API is actually identical, or this use of the API is identical to when a worker wants to send an object to another. So it's actually identical to x.send, if x.send knew about this local worker. But for now, we're going to do it this way. So the length of the message is 169 bytes, excuse me. And as we can see, it successfully sent the message over here. However, what we'd like to see is this send message actually return an object that is the return of the message. We want this socket worker to actually process the command and then return some data back to the sender. And the way in which we're going to do this is a blocking wait, where a blocking connection here, or a blocking sort of listen, right? So this prints what's being sent, excuse me, this sends the command from the client to the worker, and then this section right here, we want to, if we're supposed to wait for a response, waits until the worker sends a response back to this client, and then processes that response. Yes, and so the part of the functionality that we're not sure about yet is exactly what it's going to look like to process this response. But for now, let's just print the response. And of course, we want to send the response. So in this case, now the question is, who do we send the response to? So the message gets received by this, and here's the message wrapper. But it's not totally clear how this receiver should actually know about the sender. Previously, we had something called known workers, and I suppose that's actually what we're going to have to do here as well. So this actually wasn't going to be too hard. So if we think that this is the local worker and that's the remote client, then we have local worker dot add worker remote client as a standard way of setting this up. And on this side of things, we're actually going to need to create, this is actually the local worker on this side. And the remote client, SocketWorker. Gotta kill this one. Hook equals 2, port equals 8125. Actually, you know what would be really nice here is if I didn't have to instantiate this, because you know these workers are going to exist on their own. They're not going to have a client attached to them. So what would be really nice is if when a message was received, the message contained with it the ID, host name, and port of the worker it should be, you know, it's the message is coming from, and then if there doesn't already exist a pointer to that message, you should actually create one. That would actually be a lot nicer. So let's go ahead and do that. The first thing we need to do is actually include let's see, port, sender port equals self.port. Yeah. We really shouldn't send this every time because it's totally unnecessary after the first one, but for now we're going to keep it simple and worry about optimizing it later because that is the right thing to do. So we're going to add the sender host name and sender port. Might as well add sender ID. Cool. And then on the receiving side, in the message wrapper, see if can do it down here after the message wrapper object is created. So we're going to check and see whether or not the message wrapper, the ID in the message, we're going to check and see whether the ID sent inside the message wrapper is actually in self.known workers. So known workers is kind of a fancy, or actually it's not fancy, it's just a dictionary that contains a list of all the workers that this worker has ever interacted with. And it's used for exactly this purpose. So that when it receives a message with an ID, it can know who it is and interact with that worker in return. So if the sender ID is in the known workers, then sender equals self.known workers. Oh, actually there's a faster way to do this. If it's not in known workers, self.known workers message wrapper sender ID equals, and then we are going to create a new socket worker. Actually, we're going to say we'll call this pointer equals socket worker. Hook equals self.hook. ID equals message wrapper sender ID. Let's call it. Just trying to not have to do, just trying to keep it looking pretty. So then underscore port equals message wrapper port. Host name equals message wrapper sender host name. And I don't know, everyone always lists host name ahead of port, so might as well do that. And so we go here, port equals port, host name equals host name. Just a little bit prettier. And is pointer equals true. I'm trying to think if we want to say is client worker equals true, but I don't think we want to say that. Nope, we don't. Okay, so now we have our pointer, and we add that to known workers, and either way, sender equals self.known workers. Should put this over here. ID. And now we have a sender. Beautiful. And so if we have, this is non-blocking, well, let's make it blocking for now. It's not gonna permanently be blocking, but in this particular case we can sender dot, I believe it's just send. So now we want to send a response back to the sender. Why can I not remember what this is? Oh, yeah, it's just dot send. Oh, dot client socket dot send. And we will call this just response. Something tells me that's like an integer or something. Pretty sure it's going to be an integer. It could be wrong. And then let's just, we're going to hand code a little bit of this post-processing here, or sorry, the message preparation here. We're going to need a more generic function for doing that in the future, but until we have it, we're just going to do that here. Just, you know, get it working, then make it fast, then make it beautiful. Looks like some style errors. Let's fix those. So on line 992 we have too many blank lines. 964 we have a trailing white space. A lot of trailing white space. Okay, and then on 963 the blank line contained, man, just a doozy. Okay, and then on workers, oh, here we go, that should be everything. Test pass, okay. And now we should be able to rerun this exact functionality, and we should see the sender actually receive a response. Okay, the message was significantly longer. SocketWorker object has no attribute known workers. Now that is very surprising. Why would it not have it? I believe known workers was supposed to be instantiated by base worker, which this inherits from. Interesting. It doesn't have it. How about that? Okay, stop that known workers. Base worker? Oh, it's underscore known workers. My bad. A simple typo. Known workers. We'll fix that here, here, and here. And rebuild. Hopefully our style issues have also been figured out. Test still pass. Love it. Okay, and again, the functionality that we are hoping for here is that we will send a message here and we will receive a message in return. Connection refused because I'm a goofball. Here we go. Another error. Add received an invalid combination of arguments. Oh, it received. Oh, it returned a tensor. Okay, so what happened here was, in my sort of hack to try to return this correct response, I totally messed up. So this response is not a string, it's not an int, it's actually a tensor. Response. So instead, we're actually going to call the serialize command, and then we're going to encode it, and that is what will hopefully get returned. I actually remembered one other thing that we need to be running. So in this sender, we actually need to include that we want it to require a response, which we can do with wait for response equals true. Okay. Yeah, I've got a lot of open sockets. Okay. I repeat the same mistakes quite frequently sometimes. Boom. We got our response. That is just fantastic. Okay, so man, that's awesome. I'm actually quite surprised that. Oh, of course it got processed. So binaries get sent over the wire. This gets returned as a string. Now, in this particular case, no response is necessary. And another question that we want to ask ourselves is, where should we encode the logic for processing the response? Now, I am inclined to encode the logic not in send message itself. That's a little hacky. I know we have receive message that encodes logic, but we're actually probably going to refactor this out to some sort of triage, just so that this becomes a little bit more about just sending and receiving messages. But for now, since we're already paying attention here and we have to encode this somewhere, I am more inclined to encode this in send and receive object. Actually, that's too much complexity for now. Let's just get things working. So here's a question. Do all of these return objects? So this one does return an object. Yeah, because it's this is us requesting an object. So it actually returns the object as a response. This is the torch command. Now this one, I believe this one will also always return a tensor. Which is quite surprising. I'm a little bit unsure about this because part of that code actually I did not write, Jason wrote. But this process response. Oh, interesting. No, it returns a dictionary. Okay. Yes. Okay, so process response actually does return a dictionary, but there's a there's a pretty standard function that I believe. Before I speak too soon, let me figure this out. So this should be correct. The question is, what do we do with this response? So the tough part is that PyTorch commands can return a variety of things. Sometimes they return tuples, sometimes they return tensors, and I would imagine there are at least a few times when they don't return anything at all. And I'm pretty sure that the functionality that determines whether or not, or how to handle the different things that PyTorch can return is in fact encoded somewhere. However, I'm not completely sure where it is encoded. Okay, we're actually going to ignore this for now and treat this on a case-by-case basis. So if message writer type equals object, then print response elif message wrapper type. So when in doubt, I find that it's best to write code that's just very explicit, very simple, easy to read, and easy to debug and iterate through, and then worry about the kind of more object-oriented, good style kind of stuff afterwards. And that's what we're going to do here. So in this particular case, both of these are consistently going to return an object. This one actually does not need to. This one always will. So actually, yeah, let's go ahead and say this one won't. If it's request object, this one will, and let's say this one will return none. This one will return self.receive object. Yeah, that's the right one. So this is the one that actually, at the beginning of the last video, used to be inside of virtual worker, but because it was abstract, we're able to move it to base worker. So that should work great. And now the question is, what do we do with this guy? The trouble is I'm having trouble remembering how we were handling torch commands previously. Torch. it was a thing called receive request. I remember that. But we moved it up to base worker, send torch command. That's what it was. Okay, so it was send torch command. I'm going to go ahead and look in version control and just try to remember exactly how we were handling these responses previously. Oh, we can just look in virtual worker, because virtual worker will still have it that way. Receive message. Fascinating. Absolutely fascinating. So this actually is what is sufficient. So it actually just needs to return this tuple. So these are certainly dictionaries, so it's plausible that some of them would be serializable. However, what I'm worried about is that process response should not be handled on the server side. There we go. Okay. Because the thing that it is processing is a string. So in this particular case, send message should not. Aha. Process command result owners. This is the compiled result. This is the loaded result. Cool. Okay, so we want to take this compiled result and send that over the wire. Right now we're doing the processing on the wrong side. That's why this is a little bit confusing. Okay, great. So here's an interesting question. Why is this decompiling the result? Because yeah, this is highly illogical. It's in JSON, which is easy for us to transport, but then it's being converted back into a dictionary. But either way, both these can be converted. So basically, it's handling an edge case, not in the efficient way, but we're not worried about efficiency at the moment. So compile result returns a dictionary of information that we know how to process. So def handle command is compile result. So handle command returns that. This is the appropriate response. Send message. And then let's see, wait, send message. Oh, we're doing all the work on this side. Hilarious. Okay, so we should actually just be sending the message. So oh, we did send the message, okay. So that was the message. On the other side, it's going to handle the command, hopefully. But it should not process the response. The response should be processed on this side. So we're going to do connection, process buffer, response. Awesome. And then return response. Excellent. This is looking pretty close to me. which I'm excited about. Fascinating. Okay, this is going to be pretty close. Now, let's go ahead and build, make sure we didn't break anything too drastic. Oh, looks like we got some, oh, where'd they go? Style errors. Blank line contains white space, 956. Let's go ahead and remove that. Okay, and then that was it. Test still pass. Excellent. Probably gonna need to write some more tests though. There's one more thing that we need to do, which is to make it so that hook has a default. Oh, yes. Yes, 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 yes. Because we want to be able to pass. Yeah. Okay. So we're going to do something slightly different this time, where we're actually going to initialize the local workers ahead of the hook. And then we're going to say, and then in the hook, when we create it, so if the hook, if the local worker already exists, then it must not know about the hook, which is just being created. Thus, must inform it. Okay. So now, with these new functions, this is going to allow us to initialize workers before hooks, which is important because we want to actually use this as the local worker in an actual torch command. So let's see, local worker, client worker equals true. Oh, gotta restart it. Sometimes it gives that big error if you try to re-import it after you've done a build. Hook is not defined. There's none. Okay, 9. Okay. Same thing twice. Okay. Now we're going to say local worker listen. And if we're lucky, send remote client. Oh man, good luck with us. Haha, did not work. Okay, so the error that's here is actually not that bad. It was sending an object that it had not locally registered because it's a client worker and it doesn't register anything. So we actually just need an extra check here. So in workers.py, We still want it to check or remove this worker if we can. Visual indent is off. Okay, now we'll rebuild. Setting this up is kind of annoying. 40. Listen. Wow, look at that. Oop, errored over here though. None type has object has no attribute types guard. So it looks like so message was received. Final message was printed. The process buffer was called on connection. That might be wrong. So we want to look at line 900 in workers. We actually need to run that through our helper function first. Process buffer is our helper function. Okay, so what's the output of? That's our message. So message needs to go to receive message. Receive message. Okay, that part actually worked because this got printed out. Final message. So it was down here. So self.hook, which means that local worker. Oh, this is actually a simple mistake on our part. Now I'll run it again. We should actually probably instantiate a check there. Let's try this once more. That is quite convincing, isn't it? Local worker dot objects, and that is our object. Fantastic. Same ID and everything. Look at that. Officially sent an object over a socket using our default functionality. Now there's a chance that actually we are already ready to do other functions as well. So let's set this up again. Try our sender, hit reload, hook into it. Okay, let's do it again with a second worker, or a second tensor. We'll call it x2. x2.send remote client. Just make sure we're looking good. Ooh, probably should have received a second message. That's not good. This probably means that it hung on something. Fortunately, we can actually see exactly what it hung on. It hung on this particular accept. which is on workers.py 898. Listen. Well, let's only one tensor. It should have received 2. x2.id. It did not receive the second tensor. Now that is very surprising. It's unclear to me why that would be the case. It did not even indicate that a message had been received. And this was hanging on accept, which means the message was not actually sent, which is even more surprising. Also, I'm not completely aware of why this would be a different number of bits. Let's try it again, just see if the functionality is consistent. Okay. Still only one message. Let's get to that error in a second. So a different kind of test we can do is actually explicitly call send message. This will help us understand whether or not send is not getting called at all, right? Or whether receiver is simply not receiving the request. Okay, just double check if that one's sent. Indeed it did. Now we're going to initialize x2. But we're not going to send it this way. Instead, I'm going to send it this way. Also not received. Now let's double check this one. This one's not. This one is trying to send, even though it's not receiving. That could be it. Let's try that. Because, see, up here, we're not actually listening or trying to accept anything, whereas down here we are trying to send something, which could cause, in theory, cause an issue. I'm not entirely confident, but it's certainly possible. That does not appear to be the issue. Let's see here. I'm actually not entirely sure how to best diagnose this issue either, because it appears to be that this is hanging in exactly the place that it should be. It is waiting on the server socket to receive a message on the same place that it received one before. However, this client does not, it just doesn't appear to be sending anything. SocketWorker.send message. SocketWorker.send message. For some reason, it could be that the client socket has been closed, but this would be very surprising. To be honest, I'm not even sure how to diagnose this issue. This is a very perplexing. Maybe I've just been too close to it or too into it for too long. Let's try, when in doubt, simplify. Here we go. Okay, so instead of doing this, we're actually going to do it the old-fashioned way. Okay, that was received. What if we send it again? Not received the second time. Man, that is just the most peculiar thing. It's the same message coming from the same source. And yet this is certainly hanging at the right location. It's hanging at self server socket.accept. Which is presumably where it was hanging before, but I suppose we should go ahead and check. So if I just go like this, yep, that's exactly where it's hanging. Fascinating. And if I go over here, let's see, did I change the port? Yes, 8146. And I just say, it always says message received. Ah, only the first time. Okay, this makes me think that it's almost certainly something on the receiving side that actually is deceptively incorrect. Ooh, a new error. Return 970. Huh. Oh, I know where that is. I didn't include a new line. Tales old as time. Let's just send really simple messages. But let's include a new line. Okay, parsed incorrectly. Makes a lot of sense. Eight one four six. Send does not get received. How odd. On the off chance that it is actually this buffer that's the issue, I'm going to print the buffer as it decodes. Okay, here we go. Okay, so because the buffer is 1024 sized, it basically gets the whole thing in one buffer. So it just prints it kind of once at the end. Which means it should be returning here. Yes. And if I call this again, it does not even receive the message. That is very frustrating. Because process buffer, okay. Where is receive message getting called? In listen, most likely. Yep, receive message. Let's go. Ah, but it also gets called in send message. Oh, but that's in SocketWorker.